Hello everyone, my name is Megan Palacios. This project was conducted under the supervision of Dr. Heather Jostein at the Armstrong campus of Georgia Southern University in the Department of Biology. Today, I'm going to be talking to you about exploring temporal and spatial patterns of phenology and fecundity for Spartina alterniflora in coastal Georgia. Salt marshes play a unique role by helping to protect shorelines from erosion and helping to maintain water quality. They are also home to a variety of plant and wildlife species. Due to anthropogenic activities, there has been increased degradation of salt marsh habitats. Fortunately, efforts are being made to restore these crucial habitats. Spartina alterniflora is the dominant plant species of salt marshes along the eastern coast of the United States. It helps stabilize the ecosystem, plays a critical role in primary production, and supports the marsh food web. For this reason, Spartina alterniflora is often included as the vegetation component in salt marsh restoration projects. The purpose of this research was to characterize the phenology, meaning the reproductive cycle of Spartina alterniflora, as well as to characterize the fecundity, meaning the reproductive output and offspring survival. Our research was done along 3 different sites in Chatham County, Georgia: Halcyon Bluff Clubhouse, Rodney Hall Boat Ramp, and Lazaretto Creek Boat Ramp. All 3 sites had varying differences in salinity levels, with Halcyon Bluff Clubhouse having the lowest amount of salinity and the furthest distance from the ocean, while Lazaretto Creek Boat Ramp is closest to the ocean and has the highest salinity. The phenology was characterized by assessing reproductive status for all plants bi-monthly between September 15th and November 15th, within a quadrant every 2 meters along a 10 to 20 meter transect that was established along the creek bank and upper marsh at the Rodney Hall Boat Ramp site only in 2020. Fecundity was assessed by collecting mature spikelets at all 3 sites bi-monthly between September 15th and November 15th of 2019 and 2020. The number of seeds per spikelet was determined, and then the seeds were placed into cold, wet storage to break dormancy. After stratification, 25% of these seeds were chosen randomly from each spikelet and tested for viability using tetrazolium chloride. Germination rates were then determined, and the seedlings were monitored over the course of 5 months for growth and survival rates. Results for the phenology data showed a significant effect of date for the plant's flowering and seeding, but no significant effect of the date for the percent fruiting. Phenology results suggest a majority of plants produce mature spikelets mid to late October. For fecundity, there was a significant effect by year for the number of seeds per spikelet, with 2019 having more seeds, but there was no significant effect on viability by year. Both the number of seeds per spikelet and the seed viability showed significant effect, with a greater number of seeds at Halcyon Bluff Clubhouse and more seed viability at Halcyon Bluff Clubhouse and Lazaretto Boat Ramp. Germination rates were significantly higher in 2019, and survival rates were significantly higher in 2020. There was no significant effect of site on germination or survival rates. In terms of phenology, data from Rodney Hall Boat Ramp suggests that the best time to collect seeds is in mid to late October. Results show that there are a significantly greater number of seeds per spikelet at the site furthest from the ocean, but the viability appears to be greater nearest to the ocean. The results of this research also show spatial and annual patterns in fecundity for Spartina alterniflora in coastal Georgia, but more data is needed to establish true patterns.